Okay, up until now we have seen this formula being used various times, where we have the stiffness matrix, and then we have the displacement vector, and then the joint load vector, and the fixed end moment of the fixed end load vector. So from all of these we have already seen the F in great detail. We have seen how to calculate the F, when to use the F, what is the F. So we know that the F, the fixed end moment, is due to the loading that is on a member, on the body of a member. For example, this is member AB, and if there is some kind of load, whether it be a point load or a UDL load or an UVL load, this load, for the purpose of our calculation, we convert this load into a joint load, right? We convert it into a joint load and joint moments like that. We have seen that previously, so there's not much to talk about it since we have already covered it. Now, the thing we did not see in great extent is the Q, the joint load, because it's on the joints, right? So in this problem that we had done by now, we did not have any loads on the joints, right? So we have two unknowns. One is a VA, another one is the theta B. So VA is the vertical displacement unknown at point A, and theta B is the rotational unknown at point B. So in this case, there is no force at point A, and there is no moment, joint force at A and joint moment at B. So the values of the Q vectors are 0. But what would happen if we change this condition? So let's take a look at what happens when we change this condition. Alright, right over here you can see that there is externally applied load of 10 kPa on the upward direction at point A, and at point B you can see a downward 10 kP force, okay, that has been added. So if you look at the equation right now at the Q, if you look at the Q, you can see that there is 10 and 0. So why is there a 10 and why is there still a 0? So let's talk about that. So if you look carefully here, you can see the unknown is the vertical direction displacement, right? And there is a vertical joint point load at A. So that joint point load is going to be appearing here. That is why that is here. And the unknown at B is theta B, meaning rotation B, but there are no joint moments there. That is why the joint factor, the Q factor here, remains 0. This 10 kP is a vertical force, so if at B there was a vertical unknown, say there was a VB unknown, then this 10 kP would have appeared here. But since the unknown is theta B, only moment can appear there because moment is associated with rotation. Okay, so let's take a look at this further. If we go one step further, we'll understand this even better. There you go. This time at point A you can see a joint load and a joint moment, and at point B you can also see a joint load and a joint moment. So if you look at the Q this time, you can see there is a 10 at the BA unknown, and the reason for that is at A vertical displacement is present and that is unknown. That is why the vertical force 10 kP, the vertical joint point force, is added into this equation. And when we focus on point B, the unknown here is theta B, which is a rotational displacement, theta B, and you can see that there is a external joint moment there of 2 kP. That is why 2 is placed here, and 10 is not placed here because the unknown is not VB, the unknown is theta B, and this 2 kP is not placed here because the unknown is not theta A, the unknown is VA. Okay, so from here I think this is quite understandable and there should not be any more confusions, right? Okay, alright. Yeah, so that was it for this video. Thank you very much for watching, and I hope you got to learn something new.